Welcome back to MC Studios in Brisbane, where we performance test solar panels and crash test solar inverters in order to cut through the solar industry marketing garbage and to find out how current solar products really work. Now, let's talk about a newish inverter on the Australian market, SolPlanet. Now, 8 months ago, SolPlanet contacted me and asked me to test their inverter and obviously review it. When any manufacturer offers me a product to review, I always say the same thing. I don't do inverter unboxings. I do crash tests. And I'll test it and I'll review it. But if it's a rubbish inverter, you'll get a rubbish review. SolPlanet was up for the challenge. So this review is partly my impression after looking at the features of the SolPlanet inverter, the limited flexibility of the inverter, and I critique the online monitoring platform. But what I found most surprising was when I crash tested it. I ran it to its limit side by side with a Fronius inverter and I saw some noticeable differences. I'll get to that at the end of the video, so if you're short on time, there are timestamps down below and you can skip ahead to that part. Now, through this review, remember that this inverter is cheap. It's around about $1,000 less than a Fronius inverter and a couple of $100 less than a SunGrow inverter. So if it looks like I'm being harsh with this review, keep it in context. We're dealing with a cheap inverter, and I'm comparing it to the best inverter on the market. All I'm trying to do is point out why an inverter can cost $1,000 more than another. I'll leave it to you to decide whether it's worth the extra money, each to their own. But before we get into it, give me a thumbs up. It's free to do and it'll make you happy. And if you end up not liking the video, you can always take it back. Now, before we get to the tech stuff, let's do a quick look at the company behind SolPlanet. SolPlanet is made by a company called Isway. Isway is a Chinese inverter manufacturing company. Until now, they have always just made inverters for other companies. The most well-known brand they manufacture for is SMA. SMA is known as a quality German inverter manufacturer, but for the last 5 years or so, SMA has outsourced the manufacturing of their smaller residential inverters to Isway. I did a review of the Chinese-built SMA back in 2017, and it really didn't impress me all that much. I think it's just a Chinese quality inverter with a German badge. Now, Isway also made an inverter called Zevasolar. Zevasolar is a brand that was owned by SMA. Zevasolar had fancy marketing material and they harnessed the success of its German parent SMA. But Zevasolar's attempt to get a slice of the Australian market was a failure. They packed up and bailed out in 2019. So that's a pretty dodgy story, but to be fair, the fact that Zevasolar bailed out is really no reflection on Isway. Isway just manufactured their inverter. So after a decade of making inverters for other companies, and the same year that Zevasolar pulled up stumps, Isway started making inverters for themselves. In Australia, they branded their inverter as SolPlanet. SolPlanet is now selling inverters in 6 countries. They have an office in Melbourne with 4 staff, and half of those guys are solar tech heads, so that's a good start in my book. But here is the first question that we should ask. Can Isway make a reliable inverter? Well, maybe. The limited experience I had with Zevasolar was not very exciting, but the Chinese-made SMA is a fairly reliable inverter as far as I know. But more importantly, if an SMA inverter fails, I will bet you that SMA will be here in Australia to fix it. SMA have got a great reputation for honouring their warranty, and they have got great after-sales support. Now, will SolPlanet be around to honour inevitable inverter warranties? Well, look, I've got no idea. But SolPlanet don't have much skin in the game here in Australia. If they pull off making their mark in the competitive Aussie market, your warranty will be fine. If they don't get traction in Australia, they'll probably pull out of Australia, just like Zevasolar did, and you'll probably be screwed. Okay, let's move on and get to the real stuff. We'll start with the Inverter Build. So, at first look, it looks okay to me. It's a heavy inverter with a big heatsink, and you would think that would help with cooling, but we'll see how that turns out later. It doesn't have a screen, which is common, but I think that's sad. A screen is a useful backup to a Wi-Fi connection, and it's a simple diagnostic tool. Look, SunGrow is a quality Chinese inverter with an inbuilt screen, and I like SunGrow, but I digress. So the SolPlanet Inverter has an inbuilt DC isolator. That's great. Some cheaper Chinese inverters require an external DC isolator, which just creates more expense, more work, and more failure points. In reality, an inverter without a DC isolator can never practically be installed in an area that sees even early morning sun. That's because by Australian standards, the external DC isolator cannot ever be in direct sunlight. So the inbuilt DC isolator is a big tick for SolPlanet. Okay, now let's look at the inverter's flexibility. The SolPlanet inverter has an input current limitation of 12 amps. That's actually pretty typical for cheaper Chinese inverters, but it means you can't install panels on more than 2 orientations. So you can't do this, for example, or this. And if you're putting larger systems on your roof, you can't have more than about 12 panels on one face like this and other panels on the other face. So the current limitation makes it not the best inverter for smaller or complicated roofs. Now, at the end of 2021, SolPlanet will solve this flexibility problem, but no doubt it'll come at additional cost. They're coming out with a new range of single-phase inverters with 3 inputs or 3 MPPTs. That range of inverters will have even more design flexibility than Fronius. So when I heard that SolPlanet was soon to be offering inverters with 3 MPPTs, I got a little bit excited because 3 MPPTs can be a really good shade solution. But as I'll explain soon, SolPlanet has an important missing feature that makes it a bad option for shaded roofs. But getting back to the inflexible 5 kilowatt SolPlanet inverter that we currently have available. Let's say your house roofline is big and simple and an inflexible SolPlanet inverter will just do the job. Would I recommend SolPlanet then? No. At the time of recording, SolPlanet monitoring platform does not allow consumption monitoring. If you don't know what consumption monitoring is, you should. A consumption monitor just allows you to see how much electricity you're using, whether it be power from the grid or power from the solar. I think a consumption monitor should be considered essential when you install solar. The fact that you don't even have that option currently with SolPlanet is disappointing. Now, SolPlanet tell me that option is coming soon, but I haven't had a chance to review it. If it does have a quality and affordable consumption monitoring option, the inverter will be okay. If it doesn't, I think the inverter is just a waste of space. Now, apart from consumption monitoring, the monitoring platform is okay. It's simple enough for the end user, and it's got enough data for electricians to remotely diagnose any problems that might arise. The data is recorded in 10-minute resolution, which is pretty average, but it's not a deal breaker. But maybe you don't care about consumption monitoring, or maybe you don't care about online monitoring at all, or maybe by the time you watch this, they'll have a consumption monitoring option. So let's turn on the inverter and we'll see how well it works. I started off by doing a side-by-side performance comparison with a 5 kilowatt SolPlanet inverter and a 5 kilowatt Fronius inverter. Every now and then I hear salespeople or even installers or even electricians say, this inverter or this panel that I installed at my place, it cranks. I got 45 kilowatt hours yesterday. Now, just to point out the bleeding obvious, that's not a very scientific approach to performance testing. So I have 2 identical 8 kilowatt solar panel arrays on my roof that I use to compare 2 different inverters at the same time. I switch the inverters around to make sure that one solar panel array is not performing better than the other, and I use third-party monitoring called Solar Analytics. I also make sure that the CTs on Solar Analytics are reading the same. It's safe to say it's a fair side-by-side test. Yes, 8 kilowatts of solar panels is well oversizing on a 5 kilowatt solar inverter, but it was winter time and I faced the panels east and west. So it was a very similar sort of output to installing a 6.6 kilowatt solar system facing north in summer. So how did SolPlanet compare to Fronius? So this is the part where you think that I'm going to say Fronius performs much better than SolPlanet. Well, no, not yet. So first I tested them under normal conditions on a clear day, and they seemed to operate around about the same. And then I lightly shaded some of the panels by clamping core flute with holes in it, and I put posts on the edge of the panels, and both inverters seem to handle this light kind of shade around about the same. Now, I'm not about to keep these systems running for the next 12 months to see how they work in summer and how they work on different cloudy days and, moving shade. So I crash tested them. First, I wanted to see how the inverters worked in extreme conditions. So 2 of us threw cardboard on 2 panels at the same time and then removed them after a period of time. This is one graph that shows the results. SolPlanet just could not keep up with Fronius. So what is Fronius doing that's better? This is just a result of Fronius's superior maximum power point tracker. SolPlanet just doesn't have the same capability to make small and rapid adjustments when conditions change. But it gets much worse for SolPlanet. Through my testing, and despite what SolPlanet told me, I discovered that SolPlanet doesn't have a global maximum power point tracker. But what is a global maximum power point tracker, you might ask? While the standard maximum power point tracker makes small but continual adjustments, a global maximum power point tracker makes infrequent but potentially large adjustments to make sure you're getting the most out of your solar panels in any given situation. The global maximum power point tracker doesn't often find a problem, but when it does, it finds a big problem that was worth correcting. See this part on the chart here where SolPlanet was continually producing 700 watts less than Fronius? Both systems had identical shade. SolPlanet, however, responded poorly to that shade, and it got stuck, operating at an inefficient spot. And it only corrected itself once the shade had been removed. But if it had a global maximum power point tracker, it would have corrected itself within 10 minutes or so. So Fronius called their global maximum power point tracker Dynamic Peak Manager. You may have heard that if you're in the industry. And SMA call theirs Shade Fix. I've tested both and both work well. Other inverter manufacturers claim to have a global maximum power point tracker, but I'm dubious about these claims until I see it working properly. I've seen a few that don't work at all. It's sometimes hard to pinpoint the differences between a quality inverter and a cheap Chinese inverter. But here is one clear example. Sure, systems don't normally get cardboard thrown over them, and it's possible that in reality, a superior maximum power point tracker algorithm alone won't result in all that much performance increase over the life of the system. But to me, this just points to a bigger picture. Cheap Chinese inverters are just not built the same way. And that brings me to my next point. How does each inverter handle the heat? So there is a rule of thumb in electronics that for every 10 degrees hotter a piece of electronics operates at, the expected lifetime of that electronic equipment is halved. In other words, heat kills electronics fast. I installed thermometers in both inverters at a similar location just next to their power stacks on the top left-hand corner of the inside of the inverter. I ran both inverters with the same 8 kilowatt east-west arrays that I used in the last test. I heated the room up where the inverters were to 27 degrees, which is still cool compared to summertime. The inverters flatlined their production at 5 kilowatts for around about an hour. First, with the Fronius. The outside case got to a mild 35 degrees. The internal temperature of the inverter was 46.6 degrees. Now let's compare that to the SolPlanet inverter. The outside of the case got, pretty much too hot to touch. I measured it at 55 degrees. The internal temperature of the inverter got to 57.1 degrees. I then pushed the SolPlanet inverter a little bit harder and heated up the room to a warm 30 degrees, nothing too excessive. The the SolPlanet inverter quickly got to 60 degrees on my thermometer, or 63 degrees on SolPlanet's monitoring platform. At that point, the inverter started derating to protect itself from overheating. It reduced its power production from 5 kilowatts down to 4.6 kilowatts. But a little bit of power loss on a hot summer's day isn't the only thing I'm concerned about here. Here's the real problem. In my test, SolPlanet ran more than 10 degrees hotter than Fronius. If we made the assumption that SolPlanet used the same quality components as Fronius, then applying the 10-degree rule, we could assume that SolPlanet might last half the time of a Fronius inverter. But I think we can be pretty confident that the components used in the SolPlanet inverter are not the same quality that Fronius use. Let's hope SolPlanet are around to honour their 10-year warranty. So there's my review. In short, SolPlanet is new to Australia. We don't really know if they're going to be here long-term to honour their warranties. It's an inflexible inverter, so not suitable for complicated roofs. At time of recording, it didn't have a consumption monitor. Its maximum power point tracker isn't great, and it doesn't have a global maximum power point tracker, so I wouldn't use it if your panels are going to be anywhere near shade. It runs so hot, I would expect it to derate on a hot summer's day. And the extra 10 degrees is going to shorten its lifespan. But it's $1,000 cheaper than the Fronius, which is the best inverter on the market. So, what do you think? Would you run the gauntlet and save $1,000? Let me know in the notes down below. But if that's what you're thinking, let me give you another word of caution. An inverter is just one part of a solar system, and a quality installation is far more important than the inverter's quality. So if you choose to go SolPlanet, choose a reliable solar installation company. However, quality solar companies that intend on being around for a long time to honour warranties will often avoid taking on the risk of a new, cheap product. Quality installers use quality inverters. So if you're going solar, stop stressing about the best product on the market and start looking for the best solar installation company that's been around for a while and proven its time in the market here. So if you're in Southeast Queensland, that's obviously us. But no, I'm not going to sell you a SolPlanet inverter. Now, before you leave, give me a thumbs up and subscribe. If you want more content like this, my next video is going to be about Tigo. It's going to be a bombshell, and I've got some serious bad news if you've used Tigo without monitoring in the last several years. My name's Mark. Thanks for watching, and I'll catch you next time.